typical of any RSA in software. So we typically break even on like 300 megahertz complex CPUs if there's an RSA in software, or even only with a hardware multiplier. This is broken in maybe 10 traces, and often only in one. Okay, this was what a target actually was. So the idea is that this could be a more or less secure platform. It has locking of JTAG, it has internal flash and RAM, so you could make some software around this that kind of locks it down, and it has the RSA key in there as a secure thing, but then this is kind of the signal you get from it. Bringing me to the conclusion, well, they are different. There are obstacles and there are things that are easier. That's basically the lowdown on it. What we see is for basic microcontrollers, it's definitely a threat. And for the complex processors, it's more like, okay, depends how much you're protecting. What can you do? In the end, if you want really strong protection, you do need strong countermeasures. That's basically the message. Ask for them. If you're building something, ask your manufacturer, did you think about this? We get manufacturers only when customers ask for it, and no, never otherwise. Also, do not only think hardware is secure, because it leaks. And finally, if you really want to know what's happening, you need to measure. That's also, we sometimes are also amazed at how difficult or how easy it might be to do something like this. It's a physical process. It's not by design, so it's very difficult to say in advance something on a target. That's basically my presentation.
Do we have anybody with questions, comments, remarks? There's 1, 2, 3.
So you use a probe for magnetic field. What about grinding the chip, for example? I thought about grinding chips and then to probe the field that is stored in the flash cells, and so you can read the key that is flashed somewhere.
Like physical invasive probing of the chip?
Yes, you have to grind it, and then you have to probe the field that is stored in the capacitor of the field effect transistor.
Yeah, well, in the end, there are a lot of things possible.
Have you tried it?
Sorry?
Have you tried it?
No.
Okay. What about getting secret keys from smart cards? What is the best approach to do this?
What's the best approach? Well, there's no best approach. Power and EM measurements is what we use, but laser, let's say laser attacks are the... Well, I think maybe this is better for afterwards. Actually, a guy in the yellow T-shirt here on the first row is a guy building a laser station now. So if you want to know anything about that, ask him. And I'll be over the hill. On your left, there's a big white tent on the camping ground, and I'll be there with this setup later. So if anyone wants to see it, then.
Hi, thank you for your talk. If I understood correctly, you have your coil in the plane of the chip.
Yeah.
So you actually measure the EM component perpendicular to the chip.
Yeah.
Have you considered flipping the coil 90 degrees so you can get a better signal?
Yeah.
And you can also get direction information of the signal.
Actually, we are still also investigating that. We did investigate that and came up with the horizontal positioning. But we also see now new probes that also use vertical. So it's still, what do you want to see? And it's very indeterminate. We do see things this way, and in the vertical plane you also see things, and it's difficult to say which is better or when do you see more or what technology beneath it is important.
Okay.
Hi. So as I understood, the SBA attack, we compare the bit 0 and the bit 1 by seeing if that's a square or square and multiply.
Yes.
So if all the time either it is 0 or 1, I always square and multiply, but for the 0 I don't store it. So what is the
Well,
attack then?
It could be a solution. Your RSA will be longer in time, and you have to make sure that it's exactly the same time. We have had a situation where there was only 1 clock difference on a 3 megahertz CPU, and we could see the 1 clock difference between the real and the false multiply.
Thank you.
I'm not sure when I need to switch, so
if a CPU makes use of spectrum clocking, does that actually defeat your measurement method?
sorry, I didn't fully
If
get
the
it.
CPU uses spectrum clocking, so it actually modulates the clock by using frequency modulation or some
yeah,
other
yeah.
pattern. Does it actually defeat your measurement method because maybe you're using very small frequency band?
Yeah, varying clock is difficult, and it's also something that they now use in smart cards. It's free running clocks, and also more spectrum as a countermeasure of syncing up your measurements, because that's the problem. Every time you need to have the measurement of the crypto at the same position in time or in your measurement to do the attack. Okay?
Do we have any more questions? No? Please go and watch his demos. Job, thank you very, very much.
You're welcome.